Hi everybody, welcome to my channel again. This is Oliver. We're doing section 1.7 practice B today. Section 1.7 deals with how to represent functions as graphs. Main concepts are x coordinate and y coordinate, x or the input or horizontal axis, and y or the vertical axis or the output. Also ordered pairs is each corresponding xy value in a table. So let's start. Number one, graph the ordered pairs. So 1, 2, 3, 4, 5. We have 5 ordered pairs, 3 and 4. So we know that this is x, y. So x is 3. X is the horizontal axis. So 3 for x and then 4 for y. So wherever they intersect, that's where we draw the point. So 3 and 4 is right there. Then we have 4 and 7. 4 and 7 would be right there. Right there. Then 5 and 10. 5 and 10 would be right there. 6 and 13 would be right there. And then 7 and 16 would be right there. Okay, number 2. 2 and 5 would be right there. 6 and 7 would be right there, right? Oops. Right there. 6 and 7. 4 and 6. So 4 for x and 6 right there. 12 and 10 right there, and then 10 and 9 right there. Okay. Number 3, complete the input-output table for the function number 3, y equals 3x plus 2. When x is 0, 3 times 0 is 0 plus 2 is 2. When x is 1, 3 times 1 is 3 plus 2 is 5. When x is 2, 3 times 2 is 6 plus 2 is 8. When x is 3, 3 times 3 is 9 plus 2 is 11. And number 4, the function is y equals 4x minus 1. When x is 1, 4 times 1 is 4 minus 1 is 3. When x is 2, 4 times 2 is 8 minus 1 is 7. When x is 3, 4 times 3 is 12 minus 1 is 11. And when x is 4, 4 times 4 is 16 minus 1 is 15. Number 5, graph the function y equals x 6 minus x. Have the domain, 5 values for the domain. Let's draw a table here. We're going to calculate the range. Like that. So when x is 6, 6 minus 6 is 0, so y is 0. When x is 5, 6 minus 5 is 1. When x is 4, 6 minus 4 is 2. 6 minus 3 is 3, 6 minus 2 is 4. So the ordered pairs are 6, 0, 5, 1, 4, 2, 3, 3, and 2, 4. So let's graph the function. So 6, 0 would be right there. 5, 1 would be right there. 4 and 2 would be right there. 3 and 3, 3 and 3 would be right there. And then 2 and 4, 2 and 4 would be right there. Okay. Number 6, the function is y equals 1/3 x. The domain, 5 values. Let's calculate the range values. Okay. So when x is 6, 6 over 3 is 2. When x is 9, 9 over 3 is 3. When x is 12, 12 divided by 3 is 4. When x is 15, 15 divided by 3 is 5. 18 divided by 3 is 6. So the ordered pairs are 6, 2, 9, 3, 12, 4, 15, 5, and 18, 6. So the first one, 6, 2. 6, 2 would be right there. 9 and 3 would be right there. 12 and 4 would be right there. 15 and 5 would be right there. And then 18, 6 would be right there. Okay, number 7, y equals 4x minus 3. I have the domain. Let's calculate the range values. When x is 1, we have 4 times 1 is 4 minus 3 is 1. When x is 2, 4 times 2 is 8 minus 3 is 5. When x is 3, we have 4 times 3 is 12 minus 3 is 9. When x is 4, 4 times 4 is 16 minus 3 is 13. When x is 5, we have 4 times 5 is 20 minus 3 is 17. Okay, this is 13 here. Okay, so 1, 1. So 1, 1 would be, so this is 3 here. So this is 2, 1. So 1, 1 would be somewhere here. Okay, that's 1, 1. Then we have 2 and 5. 2 and 5 would be somewhere there. Okay. Then we have 3 and 9. 3 and 9 is right there. 4 and 13 would be somewhere there. And 5 and 17 would be somewhere there. Next one, number 8, y equals 1.2x. Let's get the table values, the range. When x is 1, we have 1.2. And then for 2, we have 2.4. For 3, we have 3.6. For 4, we have 4.8. For 5, we have 6. So 1 and 1.2. Then for 2, we have 2.4. 2.4. And then for 3, we have 3.6. And 4, we have 4.8. And for 5, we have 6. Okay. Okay, next one. From 9 through 14, write a rule for the function represented by the graph. Identify the domain and range of the function. Okay, so let's see here. Okay, so we have the domain and we have the range. Okay, so the first one is x is 0, y is 6. So we have 0 and 6, right? 0 and 6. Next one is 1 and 7. 1 and 7. Next one is 2 and 8. 2 for x, 8 for y, 3 for x, and 9 for y. Okay. So we have the domain. We've identified the domain, which is 0, 1, 2, and 3. We've identified the range of the function, which values are 6, 7, 8, and 9. Write a rule for the function represented by the graph. Okay. So what we need to do is y equals, right? We have to find the function. We have the domain, the values increase by 1. The range values also increase by 1. So this is a matter of whatever x is plus 6. We just have a different starting point. Okay, so y equals x plus 6 is the answer for number 9. Number 10, we have the domain and range. Um, 1 and 3. Then we have 2 and 7. Then we have 3 and 11. And then we have 4 and 15. Okay. So the domain is 1, 2, 3, and 4. The range is 3, 7, 11, and 15. And write a rule for the function. It will be something like that. Y equals. And then we see the domain values increase by 1. The range values increase by 4. So this has to be 4x. And then we have to adjust plus or minus. So we see 4 times 1 is 4. So we have to adjust by 1. 4 times 2 is 8. Minus 1 is 7. 4 times 3 is 12. Minus 1 is 11. 4 times 4 is 16. Minus 1 is 15. So yes, this works. So that's the rule for number 10. Yeah. Number 11, have the domain, have the range. So it's 0 for x, 5 for y, so 0 and 5, 1 and 7, 1 and 7, 2 and 9, 2 and 9, 3 and 11, 3 and 11. So the domain values are 0, 1, 2, and 3. The range values are 5, 7, 9, and 11. The rule for the function is we see the domain values increase by 1. The range values increase by 2. So this has to be 2x. and then we have to adjust with plus minus. So let's see, 2 times 0 is 0 plus 5, so this has to be plus 5. Then 2 times 1 is 2 plus 5 is 7, 2 times 2 is 4 plus 5 is 9, 2 times 3 is 6 plus 5 11. So yes, this is the function y equals 2x plus 5. This is for 11. This was 10. This is for 11. Number 12, let's do here on the side of the domain, and we have the range. We have 3 and 1, 3 and 1. Then we have 6 and 2, 6 and 2. Then we have 9 and 3, 9 and 3. And then we have 12 and 4, 12 and 4. Now the domain values, so the domain values are 3, 6, 9, and 12. The range values are 1, 2, 3, 4. The rule for the function is the domain values increase by 3. The range values increase by 1. So what we have to do, we can't multiply now, we have to divide by 3. So it's 1/3 x. So, and then plus minus, we have to adjust if we need to. So let's see, when x is 3, 3 divided by 3 is 1. When x is 6, 6 divided by 3 is 2. When x is 9, 9 divided by 3 is 3. 12 divided by 3 is 4. So yes, this is the function 1/3 x. Okay, number 13, domain and range. We have 1 and 2, 1 and 2, 2 and 8, 2 and 8, 3 and 14, 3 and 14, and 4 and 20, 4 and 20. So the domain values are 1, 2, 3, 4. The range values are 2, 8, 14, 20. The rule for the function is the domain values increase by 1. The range values increase by 6, right? So this has to be 6x, and then we have to adjust. So 6 times 1 is 6, and then minus 4 is 2, right? And then when x is 2, 6 times 2 is 12, minus 4 is 8. When x is 3, 6 times 3 is 18, minus 4 is 14. When x is 4, 6 times 4 is 24, minus 4 is 20. So yes, this is the function 6x minus 4. This is 13, and then 14. Domain, range. The pairs are 0 and 3, 0 and 3, 2 and 4, 2 and 4, 4 and 5, 4 and 5, and 6 and 6, 6 and 6. So here we have the range. The domain values are 0, 2, 4, 6. The range values are 3, 4, 5, 6. The rule for the function is y equals. The range values, we see they increase by 1. The domain values increase by 2. So this has to be 1/2 x. And then we might have to adjust. So let's see, if when x is 0, 0 over 2 is 0. So we have to do plus 3, right? Then when x is 2, 2 over 2 is 1, plus 3 is 4. That is correct. When x is 4, 4 divided by 2 is 2, plus 3 is 5. When x is 6, 6 divided by 2 is 3, plus 3 is 6. So yes, this is the function 1/2 x plus 3 for number 14. Okay, we have 2 more problems, 15 and 16. 15, high temperatures. The table shows the high temperature in degrees Fahrenheit, H, in a city during the week as a function of the number of days, D, since Monday. Graph the function. Okay, so let's see if we can zoom in here. So this is X, this is Y. So the ordered pairs are 0, 24. So 0 and 24, somewhere there. Next one is 1 and 34, 1 and 34, somewhere there. 2 and 41, 2 and 41. 3 and 39, 3 and 39. 4 and 37, 4 and 37, and then 5 and 39, 5 and 39. Okay. Describe how the high temperatures change as the week progresses. As the week progresses, we can see the temperature rises, and then it stabilizes around the second or third day. Okay. Number 16, metal screws. The table shows the number of threads per inch on a screw as a function of screw size. And this is the table given to us. We have the X and Y values. X is the screw size number X, and Y is the number of threads per inch. Under A, we have to graph the function. Okay. So 0 and 80. 0 and 80 is right there. 1 and 72 is right there. 2 and 64 is right there. 3 and 56 is right there. 4 and 48 is right there. 5 and 44 is right there. 6 and 40 is right there. That's A, graph the function. B, describe how the number of threads per inch changes as the screw size increases. So as the screw size increases, 0, 1, 2, 3, 4, 5, 6, as the screw size increases, the number of threads decrease, right? 80 from 80, 70, 60, 50, 40, 44, 40. Okay, so as the screw size number increases, the number of threads decrease. Okay, that's B. And then C, would it be reasonable to expect a number 8 screw to have 32 threads per inch? So we have 6 and then 7 and 8. So what would that be, right? So we see here the last few, they all decrease by 4. So if that's the case, then 4 less than 40 would be 36. 4 less than 36 would be 32. So would it be reasonable to expect a number 8 screw to have 32 threads? Yes. Why? Because if you look at the few values before that, for sizes 4, 5, and 6, the number of threads decrease by 4. So if we expect the same pattern, then yes, for number 7 would be 36 threads. For 8 size would be 32 threads. Okay. So that's all for today. Please like and subscribe to the channel. See you next time, guys. Thanks so much. Bye-bye.